Right, so if we have a look, all right, you got 2 seconds to gather your thoughts. All right, 2 seconds is up. Time to start. We have 3 exercises we're going to cover today. Quadratic models, circles, and determining rules. So 3L, 5D, 5E. First one, quadratic models. We did this in year 10, so it's not going to be terribly nasty to us. It's going to be fairly kind, but we just want to make sure we're all on the same page. There's a little mnemonic device there to help you if you are interested. Vespa with a double V at the start. That's one of Mrs. Tucker's favourite ones. When you're dealing with forming models, solving word problems, if you follow Vespa, it will help you get all the marks you need. Just a little quiz we did then. Some of us lost marks for not showing all of our working. Vespa. Visualize. Make a drawing. Define your variables. These are variables. Form your equations. Solve them. Ponder. Think about your answers. Sometimes we will get answers that aren't valid. Even though the maths works, we might get a negative value for the height of a building. Doesn't sound right, does it? You need to think about your answers in the context of the question and then actually make sure you've answered the question. Vespa. So there's a good little, if you haven't used that before, write that down. That's going to be of use to you. So quadratic models, not terribly complicated. A little example there. A rectangle has a length of 3 centimetres longer than its width. Its area is 42. Find its width. I'll just talk you through this one. You don't even need to see me do it. So the first thing people will usually do is I'll start writing, okay, I've got a rectangle. Let's draw the rectangle. And if I get my pen working, here's my rectangle. And we start writing length and width. And that's okay. But if I try and write my area equals length times width, obviously I've got a problem there, right? I've got 2 variables. I know what the area is going to be, but I can't solve it for the 2 variables. I have to use the other bit of information. You can either write it out as an equation, so the length is equal to the width plus 3, and then make that substitution. So now I can say the area equals the width plus 3 multiplied by the width, just replacing the L with W plus 3. You can see that it's just been labelled on the diagram on the left, perfectly fine coordination. Defined the variable. So we've got our first visualize. We've got our second V. We're defining a variable. What was the E for? Equations. Look, we did our equation. We made an equation. VVE, what's the next bit? S for solve. It's a quadratic. How do we go about solving a quadratic? Factorize, set it equal to 0, and use our null factor law. So factorizing is beautiful. We get down to this one, and we have a number of different options. You've been presented with 3 ways there. I would argue we have at least 2 more ways. I'll try and match these colours up. So we've got x squared plus 3x minus 42 equals 0. What ways have we been given? We've been given use solve-end, sketching the graph, using equation solver. They'd all involve your calculator. What if this was in the non-calculator exam? What have I got left? Completing the square, yes. Completing the square. What's the other way we could do it? Quadratic formula. All right, so every time you have a quadratic, you've got those 5 options as a way of solving. Every single time. We can go ahead and do that. Oh, why has it got a sad face for the equation solver and the polynomial? I don't know.
Because it's not.
Doesn't like it.
Okay, so equation solver is probably solver is not usually a very good technique to use because it only really works for polynomials. Any other equation like your hyperbolas and sine and trig functions and all of that, it is absolutely useless. So if you're wanting to solve something, use solven. It works for all of them with no problems. So you can use equation solver, but I would just say it's not worth bothering.
There you go. That's why there's a sad face there. I think it's sad because they didn't complete the score. It used a quadratic formula, so that's okay too. You get your answers there. They are the approximate answers. If I was being really picky, what would I do to you? If you are rounding your answers, so with your communication, you want to get your full marks for your communication. Make sure that it's obvious what you're doing. And as a reminder to you as well, as a reminder for you when you're doing your working, if I am approximating an answer, if I'm rounding my answer, I use my approximately equal to signs. We've got those signs. Let's make use of them. All right, so that's VESP. We had to ponder, didn't we? Why were we pondering our answers? What was this question about? It was about the lengths of sides on a rectangle, on a rectangular area. Does negative 8.15 make sense for the length of a side of a rectangle? It does not. So we need to reject that answer. That's the ponder. And the final bit of Vespa, answer. Answer the question. The width of the rectangle is 5.15. Did they give us centimetres? So when you're pondering what units should I be answering in? They've asked me for the width. Okay, I didn't need to find anything else. It didn't ask for the dimensions. If it asked for the dimensions, you state the width and the length. Just do what it says. Pretty easy. So we'll do a couple of those just to make sure that you're going to be okay with them. I don't imagine you're going to have many difficulties with them. We've been doing these in grade 9 and grade 10, but it's good just to remind ourselves of those little things. Why don't you have a go at question 4 right there. A piece of wire is 68 centimetres in length and is bent into the shape of a rectangle. Now, they've helped you out a little bit here. X is the length of the rectangle and A is the area enclosed by the rectangular shape. Write down a formula which connects those. Go through your Vespa. Some of it's been done for you. See how you go with that. Okay, so we've either got somewhere or we got stuck a little bit just getting started. The hardest thing is the getting started. The actual maths of this is fairly easy. So let's have a look and see if we can make sense of what I've done. The real trick, let's Control Z that because that's going to make it impossible for me to find it again. Here's one I prepared earlier. What's the key to this? It's really getting the other side length, this 34 minus X. Where did that come from and how did I get it? I think you can all go straight to that in an exam. I think it's acceptable to just write down that. But if you haven't done this in a while, you might have just needed a bit of a hand to get there, and that's perfectly okay. Once you've seen it, you'll go, oh, of course, that makes sense. They told me that my perimeter was 68. We're all happy with that. And they told me to make sure that I called the length X. Well, let's assume I don't know what the width is. So I'm just going to call it W. So if I was doing it this way, I'd write let W equal the width. Using that information, I could have 68, my perimeter, is made up of 2 times the length plus 2 times the width. I could factorize that 2 out, making sure I'm showing all my working here. Divide by 2, and I've got 34 is equal to X plus W. What I'm trying to do is eliminate one variable. So I've only got one variable in the equation I'm going to form. So I can now, if I subtract X from each side, I get the 34 minus X is equal to the width. So you can do all that working, or it's quite all right to say, okay, they told me the perimeter is 68. Well, half of the perimeter will be the 2 sides of the rectangle, so that's okay. And if one of them is X, half of 68 is 34, so the other side must be 34 minus X. If you go and write that straight away on your diagram, that's acceptable. If you just want to make sure you understand where it comes from, do the working in blue on the right. It doesn't take very long, and it's going to help you understand where you're up to. That's the most important thing. So I've done my visualize. the variables were defined for me, or I defined the extra variable w for the width. Once I've done that, I'm up to E for equations, aren't I? From my VESPA, I'm up to E for equations. Area equals length times width, which is x times 34 minus x. And that's where they asked us to stop for part A. Write down a formula which connects A and X. I have a formula for A and X there, so I've finished part A. Part B, sketch the graph of A against X for suitable X values. The suitable X values is asking us to think about a domain. We haven't really mentioned a domain too often, but the domain are the set of values that we can put into a function that will make sense. In this case, X is representing the length of that rectangle. It does not make sense for X to be longer than 34. Because if the width was longer than 34, I mean, even if I had 34, the length of 34, I'd be going 34 out, 34 back. It would be the wire folded back on itself with 0 width. That would be my 68 centimetre perimeter. I wouldn't be able to do anything else. So the maximum possible value for this would be 34. What the smallest possible value would be, if you imagine everything was width and I had 0 length. So really the number's got to be greater than 0, or you could say greater than or equal to. People will argue about whether you can accept a 0 width rectangle or a 0 length rectangle. I think it's okay to think about, but we'll say greater than or equal to 0. If you say greater than 0, I'm happy with that. And less than or equal to 34, because otherwise what am I going to end up with? I'm going to end up with negative areas. It can't be any good. So how did I sketch it for suitable values? That's already in my factorized form, isn't it? If it's in factorized form, I know the roots. The roots are at 0 and 34. How do we know that? Null factor law. So we can straight away, in factorized form, you can put the intercepts down. And that would be a sketch of it. At that point, we don't know the C value, do we? And we don't yet know this 17. But a suitable sketch would look like that. That's a parabolic equation. Part C, they get into use your graph to determine the maximum area formed. Now, we've got lots of ways of finding the maximum, don't we? Ms. Kinnear just talked about them on that little quiz. We can do negative b on 2a, substitute that value in, and get to the answer. If I've already got it in factorized form, rather than finding the x coordinate at the turning point by doing negative b on 2a, what is it that I'm going to do? Midpoint between the two roots, halfway between 0 and 34 is 17. Again, they weren't actually interested in what were the dimensions that maximize the area. They were actually asking me, what is the maximum area? So what do I have to do with that 17? Substitute it into the equation to find the maximum area. And if I put 17 into that equation, what's my maximum area going to be? 17 multiplied by 17, 289. So that, if you were using your calculator, how would you find those values? How would I find the values if I was using my calculator? G-solve, yeah, maximum. It's a maximum value. It's going to tell me the coordinates of the maximum. So be aware, you can use all of those things at your disposal. I still need to answer the question. The maximum area that can be formed is 289 what? Square centimetres, yes. It's 289 square centimetres. I know we write centimetres squared, but get in the habit of saying square centimetres. Because if someone says 289 centimetres squared, it could be ambiguous. It could mean 289 centimetres by 289 centimetres, and then multiply those together to get your answer. So even though we write centimetres with the squared after it, say squared centimetres, I still will say centimetres squared from time to time, but try and correct yourself because it's better to be precise than not. It didn't ask us what the dimensions were, but we could add it in at that point. where the length equals the width equals 17 centimetres. So that exercise 3L is just about doing those questions. It's going to be a lot of repetition of the same sort of stuff you did in the problem solving questions in grade 9 and again in grade 10. Thinking about where to set that equation up. That's the first bit. Once you set the equation up, it should be fairly easy to get through the rest of the steps there. I don't think I need to go through more from 3L. I think you've got enough of it. You'll know yourself whether you need to practice it or not. Everyone should do at least a couple tonight for homework, but I think we'll leave it there for 3L and we might move on to another exercise.